Hey everybody, this is Kyle Altair here, and in this video I'm going to be talking to you guys about using the HC12, which is a long-range radio frequency communication device utilized by the Arduino microcontroller for long-range communication. Now the best thing that I love about the HC12 is the fact that unlike the NRF24L01, you don't need any special libraries, to be honest, and the programming is pretty easy. The signal transmission distance is about 851 feet from my testing, and it went through trees, it went through buildings, it went through competing signals, so interference, and I got it to work pretty far. Now, you can possibly increase that distance by adjusting power settings via AT commands, as well as adjusting the type of antenna that is used for your device, but I'll get into all that later, as well as showing you guys how to code it within the Arduino IDE, as well as show you guys a demonstration of how far this unit can actually transmit information. So as you guys can see, I have two HC12 units hooked up. Though both are connected to the computer, they are communicating to each other purely by radio frequency, which you can see by the two antennas that are side by side. If you look close enough, you can actually see a green LED blinking occasionally on one of the HC12s, and that's actually our receiver. And if you look at the other one that doesn't have the LED blinking, that is actually our transmitter. So the way I have it set up is by having two IDEs open, I can actually program it so that so as they communicate, the LED blinks, and if there is no signal transmission, then the green LED will not blink. And you can test this by once I remove this transmitter's power, this green LED will stop blinking. So disconnect it. And there's no green LED. I plug it back in, hooks back up, starts transmitting, boots up, and now it's going to start blinking again as it receives the signal. And there we go. So that's the proof that it's communicating purely from the radio frequency and not communicating via the computer. Another thing is, I'll show you guys my PC, and we'll focus on this. Now, what I'm going to do is open up the IDE for both the transmitter and the receiver. And here we go, here. So on the left, this is the transmitter. Here is the receiver. So I'm going to go ahead and open up the serial monitor for both. All right. So here is COM8, which is our transmitter. Our receiver is COM10. All right, I just need to adjust the window so it can be smaller, so it'll be easier for you guys to see, and they're not like stomping over each other. So as you can see, the transmitter is actually sending a signal of 1 to the receiver. Let's get a little closer. You can see it says 1 and then sending signal. And then if you look at the other side, let's get a good focus. It says data received. So if I were to clear it, you guys will actually be able to see it reload. And then here I go. I'm going to go ahead and press the transmitter so it doesn't send anything. And there is nothing going on. I let it work again. It starts transmitting and it's receiving again. So that's how it works. I'll show you guys the code in a little bit, but let's go ahead and jump to that range test so you can see how far this HC12 can actually transmit. Alrighty, so this will be the HC12 transmission test. We're going to do a range test to see how far out you can go with the HC12 before it starts to lose its signal. We don't want it to lose the signal, but we want to see how far can you go with it receiving the information at a steady rate and blinking the LED at a steady rate. So here's our receiver, which is connected to our laptop, which gives us the power. And here I have my transmitter connected to my car via USB, which powers it. and it's going to just transmit a signal, and it's going to receive the signal like the LED. So without further ado, we're going to go ahead and we're going to go a couple meters, and then from there we're going to test to see if the LEDs blink or if they don't blink. So here we go. Sorry about the wind, guys. I can't help it. Mother Nature has her own little mind. So let's go ahead and get this bent. This here, as you can see, it LED currently lights. So, all right, let's go ahead and pick this heavy baby up. All right, so quick check. All right, we got blinky blinky. So let's go ahead and go out a couple meters. And I'm not doing it, I'm not being specific with it. I'm not going to go like, 5 steps or 10 steps. I'm just going to go to the point where I think there should be a difference in signal. So we're still going out. We have our car still over here, transmitting, still on. And we're going to stop, do a check. And we're still blinking, good. So now we're gonna keep going, a couple more meters. Probably gonna go here to this sign, and then we're gonna do another check. So with this antenna, I believe this is a 6 dBi antenna. When I tested it at night, I got a distance of 851 feet, which is absolutely great. All right, so we're at the sign here. Let's check and see. Looks like we got a blinky blinky. So we're gonna go out farther. Next we'll head to those yellow poles, and then we'll see what we get. So the place is absolutely beautiful. Just chose a random place that looked nice. Good little park, and yeah, found this place, and I'm just doing a test, So I imagine nighttime, during the night, tend to have better signal transmission than in the daytime because it's cooler. People tend to be asleep, which means their devices are off, so your interference sources will be muted, especially compared to when you have them on in the daytime and everyone's awake, hustling and bustling. So here we are. We are at the yellow poles. And unfortunately, it looks like we don't have a signal. However, we may be in the critical range. There is a certain measurement away from the receiver, the transmitter, I mean. There is a certain measurement away from the receiver and the transmitter where it just won't work. So what we'll do is we'll head over yonder, over here, to this trash bin, because I need a place to actually set this down. Actually, this might work. Here's hoping I don't drop it. Alright, so I have it balanced on my stomach and on my hand, and I lifted up the antenna, took it away from the computer, and it looks like we got a good blinky blinky going. So now we're going to go to that trash can now, since that's our next elevation source, and go from there. Alrighty, so looks like we got our blinky blinky. This was the farthest I can get it, plus or minus like a couple feet. And here is our transmitter way over here. And yep, here we are. Oh, place is called Pine Lake apparently, so that's cool. Cool place. Yeah, and we still got our blinky blinky. So yeah, this is pretty darn far. I don't think this is 800 feet. I think 800 feet would be closer to over there. This house right here, I think that'd be closer to 800 feet. However, that's some pretty serious distance. So let's go to the map and we'll see how far it is. Alrighty, so we are on Google Maps. So here's the trash can right here where I was. We're gonna go ahead and set that, drop that pin directly on the trash. Oh, well, wait, we're not trying to do that. Sorry, guys. This is where we were, though. Beautiful view, absolutely beautiful. This is not what we're looking for, though. All right, let's go back here. Here's the trash can. Measure distance, there. And now let's go to where the car is, which is roughly right about here. And distance to here. Okay. And let's move that pin because we were about, I want to say about here. So it looks like the maximum signal transmission from during daylight is approximately 503 feet. Wow, that is a lot. So the nighttime, because it was colder and it was colder, more people were asleep, so less interference. Because of those factors, we had a lot less signal issues. So that's why at night it tends to be a lot. The signal can travel further, but in the daytime it can't travel as far. So 503 feet is pretty good. So we're here on our trusty calculator, and we're going to see the difference. So it was about 851 feet minus the 503.76 feet. We have a loss of 347.24 feet. So, it was a bit of a difference in distance, but it's still pretty good. I mean, 503 feet during the daytime with all this interference and whatnot, it's still pretty darn good. What that also means is if you have it in your house, that you'll have, it will cover all of your house, unless you have a house that's over 500 feet, in which case, can I please live there? So we're going to go ahead and switch to the code now, and we're going to talk about the AT commands and all that good stuff. So let's go ahead and switch to that now. Alrighty guys, so here we are at the Arduino IDE. You can see we have two IDEs set up. One is the HC12 sample transmit, which is in the car. The other one is the HC12 sample receive. So this is going to be quite straightforward. First thing you want to do is have your software serial. Then you want to have your set pin as 6, though you can have it as any digital pin that you choose between 0 and 13. I say 0 through 13 because I'll talk about this in a different video in further detail, but the TX and RX of your Arduino can actually be disabled if you put serial.end and then put into parentheses and then your semicolon, but I'll get into that in a later video. However, for now, this would be quite simple. Your set pin, if you look on an HC12, is just called set, so we just define it as being on pin 6. Your software serial HC12, this is very important. This is your TX and RX pin, respectively. Right now we have it on 5 and 4, though we can have it as any of our digital pins. Then you have your incoming byte, string, read buffer, quotation marks, which clears it. Here's your serial begin. Your set pin is output. You want to set it as high. If you have your set pin as low, it enters command mode, which is where you can configure different values of your units, which would be the power level, the baud rate, different things like that. And then afterwards, you set it to high. And then while HC12 available, incoming byte. This is what stores the incoming byte. Forgot to put that. There we go. The incoming byte from the HC12, and then add each byte to the read buffer string variable. Then between every time you change like a state or whatnot, it's best if you give it a couple milliseconds to actually adjust. So here we give it a second, not a second, we give it 100 milliseconds. And while serial.available, so whatever you put in the HC12, whatever it writes, the serial monitor will read. And at the bottom here, whatever the serial monitor writes, the HC12 will read. So it's like a loop. Here we delay by 1 second, and then we have HC12 write 1, and then that broadcasts out. We have it print on the serial monitor that it's sending the signal, and then while HC12 is available, and it goes back to that feedback loop that we just talked about, and then you clear your read buffer. Here in your receiver, you go down in the code, and you'll see that if read buffer equals 1, 0 print line data received, and you want to print line all these asterisks. What you also want to do is HC print read buffer, and that'll be in the serial monitor, and you will turn your green LED high for 100 milliseconds. Then you want to have it low for 100 milliseconds. So if you want to go into further detail of just like the baud rate, the power level, the broadcast rate, and everything, I will have a link in the description to this manual here, which is the HC12 wireless serial port communication module. And this covers everything, such as how to set the channels, how to set the power level. It gives you a lot of information. I won't go into detail here due to the fact that most of you guys may have not had heard of an HC12. So I'll give you guys the option of going to further, getting into the meats and potatoes of it if you choose to. However, that won't be something that I cover here. Just know, one thing I will tell you is that if you want everything to be standard, you want to do a default AT command. And that's if you want to. You don't have to, since they typically, all the HC12 units are typically already in default. However, the manufacturer may or may not have set it to default. It's possible. So what you could do here is, here in your output where you have digital write set pin is high, what you could do is have digital write set pin low, wait 100 milliseconds, and then you want to do a print and HC12 dot print AT plus default, and then that'll set all your values to the default, which means that your serial port baud rate will be 9600 bits per second, your communication channel will be 1, and your serial port transparent transmission mode will be FU3. Again, if you want to look at what FU3 means and all this other information, I'll have a link in the description. One big thing I want to cover that is covered in this manual are the channels. Now, if you want to, you could have the set pin as low and then do the AT command to set your channel, which you can find here. Hold on, let me grab it for you. Here. So the AT command would be AT plus C, and then you set whatever you want it to be. Here's the example here. If you want to set it to channel 21, you would have the set pin low and then send AT plus, do a HC12.print, AT plus C021 command, and then it'll return OK. And then once you exit it, it'll now be on channel 21. Now, if you want to do this, that is perfectly fine. However, what I think is a bit better is that you have each of your units, your receiver units, look for a specific value. So here in our sample HC12 sample receive, we have our receiver unit looking for the value 1. What you could do is set each receiver, for example, if you wanted to get a reading of a DHT12, you could have DHT12 activate, and then your receiver, though they're all on channel 1, only that specific unit is looking for that specific phrase to be broadcasted. Once it's broadcasted, it would then send the data to the transmitter, and since the transmitter is looking for a specific value, it would then print that specific value. So it's not too complicated, it's pretty simple, but you guys can research it, look it up with this manual and decide on what you want to do. It doesn't matter either or, because there are just different ways of getting the same thing accomplished. It's just a matter of preference, to be honest with you guys. So without further ado, let's open and see if this is actually still working. We're not on COM 8 anymore. Looks like we are on COM 10, I want to say. Open COM 10. Let's see if this baby is still working. Yep. So it's still receiving data as we speak, and as I look at it now, it is still activating the green LED. So that's the video, guys. Thank you for watching. This is a lot better in my opinion than the NRF24L01 due to the simple fact that not only can you customize the specific pins, the transmit receive pins, as well as your set pin to any pin on the Arduino, pin 0 through 13, you can also customize a lot of it without a lot of complexity. So it's super simple, easy to use. The transmission range is very far. We got over 500 feet in the daytime, and at nighttime we got over 800 feet. So all you need to do if you want to increase your range is set the power output to the highest value. You want to set your baud rate to the lowest value possible, and you want to change your antenna. I have a 6 decibel antenna. What you guys can do is increase it to a higher gain, and by increasing it to a higher gain, you can go a lot farther. So this is the video, guys. Thank you for watching. Please like, share, subscribe, and tell me in the comments what you think. Questions, comments, concerns, and I'll be happy to hear you guys out. Please follow my Instagram, which was also called Kite Talks About, and I'll see you guys in the next video, and goodbye.